Okay, so here we have the notes, examples and practice questions for probability. It's the second lesson on probability, so grab your notes folders, notebooks, wherever you're writing this, and start with the title, probability, and then we want a subheading because it's the second probability lesson, which is this here, so outcomes, listing outcomes, sample space diagrams, and complements. So this will all make sense as we go through, but that's the subheading. Write that down for me. Okay, great. So starting with our notes, we're going to start with writing that we can list all outcomes methodically for multiple events occurring. So sometimes we're going to have experiments where there's more than one thing happening, and we want to be logical in the way we write down those outcomes. Often a sample space diagram is useful for showing outcomes. So we're going to explore those. And then P not A means the probability of not A. So that is the opposite of A, and that's actually called the complement. So P not A is called the complement. Now, what that means is the probability of A or the probability of not A equals 1, because either we've got to have A or not A. And then super blue box, again, that is what it was last time. Assume all dice and coins are regular unless you're told otherwise. So once you've written down your notes, we want to do the examples. So the examples, we want to have a little subheading, keep these in our notes, nice and neat, and off we go. Okay, so example number 1, we're going to write this down nice and neatly. So a fish and chip shop serves 2 main courses, cod and haddock, and 2 sides, chips and mushy peas. List all of the possible outcomes. So what we want to do is we want to list the outcomes, but we want to do it logically. So we're going to start with cod. So we're going to have cod, and we could have cod with chips. Or we could have cod with mushy peas. And then cod is finished. Okay, so we can ignore that. And next we're going to look at haddock. So then we've got haddock, and we could have haddock with chips, or we could have haddock with mushy peas. And then haddock's done. And that is actually all of the outcomes. And because we've listed them in a logical way, we're not thinking, right, cod and mushy peas, haddock and chips, cod and... wait, which one? So we're just doing it logically, working through. We've got chips with cod and chips with haddock, and we've got mushy peas with cod and mushy peas with haddock. So as long as we exhaust our options like that, we get through all of our options. Okay, now we're going to look at a dice and a spinner. So a dice is rolled and a spinner is spun. Show the possible outcomes in a sample space diagram. Okay, now if we look at our sample space diagram, what we can see is we've got a spinner along the top, and then we've got a coin. So this, I'm really sorry, it should say a coin is flipped. So a coin is flipped and a spinner is spun. Show the possible outcomes. Now, if they happen at the same time, my first outcome is I could get a head and a 1. And so I can insert all of these options, and that's in a really logical manner. Okay, so I've got all of the options for my spinner here, and I've got all of the options for my coin here. So then my other options are these. So we have all of our options there, and a sample space diagram helps us to show all of the options in one place, and we go through them methodically, not missing anything out. Okay, question 3. I will either pass or fail my driving test. If the probability of pass is 0.65, what is the probability that I fail? So fail is the same as not pass. They're my only 2 options. So if they're my only 2 options, they have to add up to 1. So therefore, the probability that I fail is 1 minus 0.65, so 0.35. Why do they have to add up to 1? Because they are the only two options. And probability has to add up to 1, which we know already. Okay, there we go. So they are our notes. Let's do a quick summary. So what we want to do is we want to work logically through our possible outcomes. So that was our first thing, work logically through. The second thing is our summary is probably, so a sample space has one event along the top and one event down the side. And then finally, we know already, but we're just going to write it again, probability adds up to 1. Big red box goes around there. There we go. The practice questions will mirror these, so if you're stuck, you can come back and you can have a look. Okay, so practice questions. Okay, so part A. I select a counter from the bag's here, and spin a coin at the same time. List all of the possible combinations I could get. So we want to try and do this as logically as we can. Okay? So when I spin the coin, I'm always going to have the option of heads. And so I could have heads with red. I could have heads with blue. I could have heads with yellow. Or I could have heads with green. So I've got red, blue, yellow, green. And then I could have tails with all of those options as well. So that's not the only way of doing it, but that is a nice logical way. And they are all of the combinations. Part B, I spin 2 spinners. Complete the sample space diagram for the possible outcomes. Okay, so we've got spinner A here with 1 to 4 and spinner B here with 1 to 3. So I could get, so this here is 1 and 1. So that's 1 and 1. 1 and 2, 1 and 3, 1 and 4. This one here is now 2 and 1, 2 and 2, 2 and 3, 2 and 4. And then 3 and 1, 3 and 2, 3 and 3, 3 and 4. So they are all of my outcomes in a sample space diagram. Okay, question C. I roll 2 dice and add together the scores. Draw and complete a sample space diagram to demonstrate the possible scores. So we have 2 dice. Just going to put these boxes in. So that's what your sample space should look like. And as we can see here, I'm adding together the scores. So again, we're following this kind of schedule here. So that's 1 and 1. So 1 and 1 is 2. 1 and 2 is 3, and so on. And now I have 2 and 1. So that's 3, 4, 5. So I can just add these up. And there we go, that is my answer. Okay, finally, we're completing the table here. Okay, so in bag 1, now all of these probabilities have to add up to 1. So all probabilities add up to 1. This is the probability of green. Everything else is the probability of not green. So these all add up to 0.9. So that's all add up to 0.9. So what's left is 0.1. Okay. Next, it tells us in bag 2, probability of yellow equals the probability of green. So yellow equals green. Okay, well, I've got already 0.6 plus 0.1 is 0.7. So what's left over is 0.3. And if they are the same, that goes like so. Okay, now B, this is a real stretch question. So in bag 3, probability of B is 3 times the probability of R. So what I'm actually going to do is I'm going to call red X, and the probability of blue is 3 times that, so that's 3x. Now I know that all of these add up to 1. Now that's 4x, that's 0.6, so therefore I can solve this as an equation. Divide by 4, so x equals 0.1. So in here we get 0.1 for x and 0.3 for 3x. So that's the whole idea, that probabilities add up to 1. If there's anything you're still not sure on, do get in touch. Ask somebody, rewatch the video, make sure you're confident with that.